Yellowstone is one of the country's most visited national parks.
From a bird's eye view, this Alaskan megavolcano looks peaceful.
They are watching, waiting, and tense. The scientists at the U.S. Geological Survey (USGS) are on pins and needles as indicators mount. Some 21 volcanoes across the nation now show signs that their magma systems might be on the brink of eruption. Seismic tremors are rising, gas emissions are fluctuating, ground inflation is accelerating in places, and a growing chorus of warning signals suggests those below the surface might finally break free. Before we start, smash the like and subscribe buttons for more updates. Deep under Yellowstone's vast caldera, and in the shadowy reaches of Alaska's Aleutian chain, the Earth is murmuring. In certain areas, it is whispering in tremors. In others, it is shouting through increased gas release or swelling rock. The USGS has developed a careful alert notification system that tracks volcanic activity across the country, from normal through advisory, watch, and warning. Their models now indicate that a significant proportion of these 21 volcanoes are shifting upward in risk, inching closer to eruption thresholds. The nation might be on the cusp of a volcanic awakening, and many in the field believe this is not a distant possibility, but an imminent danger. The worry begins with the nature of volcanic systems themselves. Volcanoes are not static monuments. They are dynamic, living systems of heat, pressure, and molten rock. Magma chambers refill, fractures evolve, gas pressures rise, and stress is redistributed among cracks in the surrounding rock. Sometimes a volcano that has been quiet for decades can rouse itself with little obvious warning, while others may smolder for years before a final push leads to rupture. The 21 volcanoes now under close watch are those where the balance of forces suggests they could erupt any moment. Their internal conditions appear fragile, stretched, and near the edge. One of the primary alarm bells is seismicity. Volcanoes often talk by way of earthquakes. Small, shallow tremors as magma moves, fractures rock, or forces its way upward. In many of these 21 sites, the frequency and intensity of volcanic earthquakes have risen sharply. Swarms of quakes cluster under volcanic edifices where formerly there was silence. The pattern of tremors sometimes looks more like the opening of subterranean cracks than tectonic motion, hinting that rock is under immense stress, being ripped apart by upward pressure from magma. In the most advanced cases, scientists are seeing harmonic tremors, more continuous rhythmic ground vibrations consistent with fluid movement. That suggests magma or volcanic fluids are no longer merely perched deep below, but may already be migrating upward into shallower conduits. Another key sign is ground deformation. Modern geodesy, GPS, satellite radar INSAR, tilt meters, allows volcanologists to detect minute changes in surface elevation, bulges in the ground, or subtle tilts as magma forces its way upward. Several of these high-risk volcanoes now show accelerating uplift in their summit regions or flanks. In some cases, deformation has migrated outward from central vents, as magma pressurizes side dikes or intrudes laterally. That kind of spatial pattern of inflation is especially ominous. It may point to multiple pathways by which magma could erupt, making forecasting more difficult and emergency planning more complex. Gas emissions and chemistry changes are another component of the alarms. As magma ascends, dissolved volatile gases like sulfur dioxide, carbon dioxide, hydrogen sulfide exsolve, expanding and escaping through cracks. In many of these 21 volcanoes, gas emissions have increased, not merely in volume but in changing proportions. The ratio of CO2 to SO2 or fluctuations in trace gases like helium isotopes sometimes shifts as fresh, deeper magma intrudes beneath older reserves. In a few cases, existing fumaroles and vents are venting more sulfur dioxide, and new fumarolic activity is appearing in places that were dormant. Scientists are also measuring subtle temperature anomalies, hydrothermal alteration, and changes in groundwater chemistry near volcanoes, all evidence of magma forcing its way upward. Then come the pressure changes. The internal pressure in a volcanic system is not uniform. Over time, magma injection, volatile release, and tectonic stress perturb that balance. Some of these volcanoes are showing signs of rising internal pressure approaching critical thresholds. In laboratory and field models, when pressure gradients exceed a certain threshold relative to rock strength, fracturing occurs and magma can break through. Some of the monitored volcanoes appear close to that tipping point, a hair's breadth from failure. One of the deadliest unknowns is timing. Even with all these signals, predicting precisely when a volcano will erupt remains notoriously difficult. The USGS scientists are acutely aware of that. Many volcanic systems slip into chronic unrest. Years of elevated seismic activity, ground deformation, and gas emissions without culminating in major eruptions. But that too is dangerous. Communities near those volcanoes live under prolonged stress and uncertainty, wary of what could happen next. The risk may stay high for months or years, or it could erupt tomorrow. For those volcanoes classified under watch or warning status, the atmosphere in the control rooms is electric. Researchers pore over every additional data point: new quakes, shifts in tilt, satellite images of cracks, changes in gas signatures. They run simulations of potential eruption scenarios, lava flows, pyroclastic activity, ash plumes, lateral blasts, and multiple vent openings. They cross-check hazard maps, evacuation plans, and intersections with population centers, infrastructure, and air corridors. One reason for urgency is that many of these volcanoes are located near communities or essential infrastructure. Ashfall can cripple agriculture, contaminate water sources, clog engines and air filters, collapse roofs, and trigger respiratory problems. Aviation is especially vulnerable. Even small to moderate volcanic plumes can ascend into skylanes and disrupt flights. The USGS uses an aviation color code system green, yellow, orange, red to classify the airborne risk of ash. If one of these erupting volcanoes sends ash aloft, it could disrupt commercial air traffic across wide regions. In some regions, volcanoes lie near critical economic or population hubs. As magma pressures rise, there's no guarantee that eruption will remain small or localized. Eruptions could open unexpected vents or fail on flank positions, leading to lava flows cutting off roads, isolating towns, or threatening utilities. In moments, a hazard once underground could become a surface disaster. Consider Yellowstone. Though not currently showing eruption-level signs, the Yellowstone Caldera is under constant scrutiny for subtle movements. Even small deviations in its baseline behavior can spark speculation and renewed attention. Were Yellowstone to slip into a more active state, the implications would be national in scale. For now, Yellowstone remains at background levels, but it serves as a reminder that supervolcanic systems lurk deep underground. Farther west, the Cascade Range in the Pacific Northwest is a known chain of volcanoes that have historically produced violent eruptions: Mount St. Helens, Mount Rainier, Mount Hood. Some of the 21 volcanoes under watch likely lie in that volcanic corridor. A renewed eruption sequence there could threaten cities, disrupt power grids, sever highways, and send ash clouds across agricultural zones and urban areas. In Alaska and along the Aleutian Islands, many of these under-observation volcanoes occupy remote and rugged terrain, but their eruption would pose grave danger to air traffic crossing the North Pacific. If ash reaches cruise altitudes, jets could inhale ash, leading to engine failure. Eruptions in remote zones can also be unpredictable. Flank failures, lateral blasts, or pyroclastic surges might reach zones beyond mapped expectations. This looming situation has ignited a rush among USGS and partner observatories. Upgrade monitoring, improve early warning systems, deploy additional sensors, and refine models. The National Volcano Early Warning System, NViews, is part of this effort, designed to scale monitoring according to threat levels and unify data sets across regional observatories. The fact that so many volcanoes are now flirting with instability accelerates this transition. The more signals scientists receive, the clearer the patterns may become, but also the less reaction time there may be before an eruption breaks through. There is also concern over cascading effects. The eruption of one volcano could stress nearby systems, triggering others. Large earthquakes associated with magmatic movement or regional tectonics could adjust stress fields, making other volcanoes more likely to slip. The Earth's crust in volcanic regions is interconnected in complex ways. What happens beneath one peak can propagate pressure changes outward. If one volcano in the network lets off pressure, underlying stress could shift elsewhere, nudging a nearby volcano closer to failure. Another complicating factor is magma mixing. Many volcanic systems host multiple magma bodies, deeper, hotter magma mixing with older, cooler magma. When these mix, volatile gas content can change rapidly, and viscosity changes can lead to explosive transitions. Some of the 21 volcanoes under scrutiny may contain stratified magma reservoirs ready to mix, producing sudden surges in gas pressure and explosive potential. Because of these complex interactions, scientists are especially cautious about false positives. They must balance raising alerts with the risk of premature evacuation warnings. Each additional alarm must be justified by multiple lines of evidence: seismic, deformation, gas, thermal, hydrologic, to avoid crying wolf. But now, with 21 volcanoes inching closer to eruption states, that balancing act becomes ever more delicate. The timing window is unpredictable. Some volcanoes might erupt in days, weeks, or months. Others may linger in elevated states for years before a final break. But the consensus among observers is clear. The current conditions in these 21 sites mark heightened volatility. Scientists believe that we are at one of those periods where multiple volcanoes could erupt nearly simultaneously or in quick succession, pushing volcanic hazard awareness and emergency readiness into overdrive. Communities near these volcanoes are now under a shadow of uncertainty. The possibility that one of these volcanoes might erupt suddenly spurs urgency in local and regional governments. Emergency planners are on high alert, examining evacuation routes, communication protocols, ash mitigation strategies, and resource deployment. Insurance agencies are rethinking coverage near volcanic zones, and scientists are locking in observation windows and rehearsing sudden alert escalations. The beauty and terror of volcanic eruption lie in their unpredictability and raw power. When magma breaches the surface, it transforms landscapes in hours. New lava flows, ashfall, pyroclastic surges, gas release, and sometimes even flank collapse or volcanic landslides. The energy stored beneath volcanoes is immense. When released, it reshapes mountains, burns forests, and reshapes watersheds. For the 21 volcanoes now edging toward eruption, that latent power is closer to breaking through. Public attention is likely to sharpen. Media will scan reports from each observatory. Citizens will watch live seismic graphs, tilt maps, and gas emissions. The most sensitive of these volcanoes may prompt real-time broadcasts, web updates, and scientific briefings. In the days ahead, any change in tremor patterns, sudden inflation bursts, or new fumarolic activity could make headlines. The USGS has long produced volcano alerts and notifications built on observed data and modeled scenarios. That system will be under stress now as multiple volcanoes approach threshold states. One positive aspect is scientific readiness. The USGS and partner institutions have decades of experience in volcano monitoring, hazard maps, and eruption modeling. For many volcanoes, advanced monitoring networks already exist. Seismometers, GPS stations, tilt meters, gas analyzers, remote sensing, drone surveys, and satellite imagery. Scientists are not blind to these shifts. They have been tracking rising activity for months or years in some cases. What's new is the clustering. Having so many volcanoes simultaneously nearing criticality stretches departmental resources, demands coordination, and tests early warning systems. Still, the unpredictability remains. In volcanic science, nothing moves in perfect linear fashion. Many volcanoes oscillate, accelerating then pausing, reviving then stalling, fluctuating pressure dynamics. Some will cross the eruption point, some may revert to lower activity. Exactly which ones will erupt, when and how violently remains unknown. But what is not unknown is that these 21 are in a class of heightened risk. They have moved out of the realm of quiet or moderate unrest and into the precarious edge. For now, the USGS and observatories will continue to push out alerts, to refine models, to compare with historical analogs, and to prepare for every eventuality. Scientists will be scanning every new microseismic event, every minor tilt change, every gas pulse, and every thermal anomaly. In the background, civil authorities will weigh evacuation thresholds, public advisories, air traffic rerouting, and community safety measures. The nation may soon confront multiple volcanic hostilities at once. This is not just a geological curiosity. The uncertainty is potent. The window for warning may shrink faster than anticipated, and if a volcano does erupt, it may do so in a way that defies expectations, opening fissures, sending ash in unexpected directions, or coupling with local hydrology if snow or glaciers are present to trigger lahar flows. In the coming hours and days, scientists will chart each indicator with razor focus. The public will instinctively watch the Volcano Observatory web portals. Every tremor cluster, inflation pulse, gas emission spike, or crack opening could be the final sign before a rupture. The 21 volcanoes under watch now are the hotspots of risk in the U.S. The question is not whether one or more will erupt. The question is when, where, and how violently. The Earth beneath is alive, and it is restless. We stand at a moment of high tension. The subterranean drama is reaching a tipping point. Soon enough, the magma that has crept silently under the crust may break through in fire and ash, and the long-dormant giants may roar awake once more. As the tension rises within the U.S. Geological Survey command centers, there's a palpable sense that nature is orchestrating something vast, unpredictable, and beyond complete human control. The analysts and volcanologists, some of whom have devoted their entire lives to understanding these fiery giants, now find themselves confronting a convergence of signals unlike anything seen in decades. 21 volcanoes exhibiting concurrent signs of unrest is not a statistical anomaly, it's a geological reckoning. Across labs, field stations, and remote observatories, data streams in from sensors perched on slopes, satellites orbiting high above, and research vessels navigating the seas near volcanic islands. Each reading carries the potential to confirm a shift, from dormancy to awakening. The magnitude of the situation extends beyond the mere scientific thrill of discovery. It touches on the fragile interdependence between civilization and the natural systems beneath it. The continental crust of the United States sits atop a mosaic of tectonic boundaries and hotspots, zones where the Earth's interior energy seeks release. As magma pulses upward, it exploits faults, weaknesses, and ancient conduits that have lain sealed for centuries. The immense pressures involved, sometimes exceeding thousands of atmospheres, can fracture solid rock and deform entire mountain flanks. When the USGS identifies 21 volcanoes on the verge of eruption, it's not only a matter of molten rock, but a symphony of interconnected forces echoing through the crust and mantle. At Mount Rainier in Washington, the stakes are particularly high. Its glaciated summit conceals vast reserves of ice that, when melted by eruptive heat, could unleash lahars, torrents of mud and debris that can race down river valleys at tremendous speeds. Seismographs around Rainier have recently detected swarms of tiny quakes, each like the faint tick of an internal clock counting toward a moment of release. Thermal imagery reveals patches of warming along crevassed areas, while gas sensors register fluctuations that suggest magma is migrating upward beneath the edifice. If Rainier were to awaken, even modestly, it could send cascading hazards through the heavily populated Puget Sound region, threatening towns that lie within the lahar pathways mapped decades ago. Farther south, Mount Hood in Oregon and Mount Shasta in California have each demonstrated low-level activity that commands close attention. Ground deformation instruments around Mount Hood record subtle uplift, indicating inflation within its magma chamber. Shasta's flanks, meanwhile, have experienced a slight but measurable expansion, and fumaroles have intensified near its summit crater. While these signs alone might not foretell imminent eruption, taken collectively with national patterns of rising unrest, they contribute to the USGS's heightened state of alarm. It's the simultaneity of these signals that unnerve scientists. Many volcanoes, spread across distant regions, appear to be stirring at once. In Alaska, the Aleutian Arc has always been a restless boundary between tectonic plates, a line where the Pacific Plate slides beneath the North American Plate, driving intense volcanic activity. There, several peaks, including Shishaldin, Cleveland, and Pavlov, have entered new phases of instability. Satellite sensors track ash and steam emissions, intermittent explosions, and persistent tremors that ripple through the chain like pulses along a nerve. For Alaskan residents accustomed to living near some of the world's most active volcanoes, these developments still inspire caution. The U.S. military and aviation authorities monitor the airspace continuously, aware that a single unexpected eruption could send ash high into trans-Pacific flight routes, endangering aircraft engines and forcing widespread flight cancellations. The scientists also turn their gaze to the Pacific territories, places like Hawaii, where Kilauea and Mauna Loa dominate the volcanic narrative. Kilauea's activity, though long studied, continues to evolve. Variations in gas output and ground deformation indicate that magma may be reorganizing beneath its surface. The delicate interplay between these Hawaiian volcanoes is an ongoing reminder that volcanic systems are rarely isolated. Magma transfer between reservoirs can shift pressures unexpectedly, leading to sudden outbursts. If multiple volcanic systems in Hawaii were to become restless simultaneously, the islands could face disruptions far beyond localized lava flows, from air quality hazards due to sulfur dioxide to potential impacts on power grids and water supplies. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on the USGS warning about 21 volcanoes possibly erupting soon? We want to hear from you. Thank you for watching, and see you next time.